Okay, wonderful. So thank you all again for being here tonight. And with us, we are really honored to have Dr. Pey-Yi Chu. She's a historian of the Russian Empire and Soviet Union whose teaching and research focus on modern Europe, Northern Eurasia, environmental history, and the history of science. Her work explores how physical environments and intellectual traditions in Northern Eurasia have stopped global scientific knowledge, have shaped global scientific knowledge. She's the author of The Life in Permafrost, A History of Frozen Earth in Russian and Soviet Science, which traces the development of permafrost as a scientific concept and explores its broader environmental and geopolitical implications. The book was awarded the W. Bruce Lincoln Book Prize by the Association for Slavic, East European, and Eurasian Studies. Dr. Chu's current research investigates Russian and Soviet scientific expeditions in Central Asia and the Eastern Bloc's role in the International Biological Program during the Cold War. Her work has been supported by the U.S. Department of Education, the Social Science Research Council, the Davis Center at Harvard University, and the Rachel Carson Center in Munich. So I would like to welcome for all of us Dr. Pey-Yi Chu, and she will present to us about the permafrost. So welcome.
Thank you so much, Sandra. Good evening, everyone, and thank you very much for being here today. It's really an honor to be invited to speak with teachers about my work. So I understand that as a collective, you've been delving into the past and present of environmental challenges and transformations across Eurasia. And you've been hearing from distinguished scholars about how peoples and states in Eurasia have interacted with the material world, utilizing resources and changing and often degrading the landscapes. So today, I'm going to share my screen. Today, I'd like to take what might be a slightly different approach to the environment by delving into the history of science, how we know what we know about the environment. So my focus is not only on how humans have interacted with and impacted the environment, but also on how these interactions generated knowledge about the environment. I focus not only on how political goals and needs shaped human interactions with the environment, but also on how these political contexts shaped scientific ideas. So becoming aware of the political dimensions of environmental knowledge can help us see where our understandings might fall short and encourage us to consider additional perspectives about nature. So in my presentation today on unearthing the history of permafrost, I'd like to emphasize two big picture points. One is that permafrost has a history, including a political history. It's not a straightforward natural phenomenon, nor is it a neutral scientific term. The idea of permafrost originated and developed in the particular political context of the colonization and industrialization of Siberia. Secondly, the idea is that the history of permafrost as a scientific object highlights complexities in the relationships between human and non-human nature in the Soviet Union. It reveals the Soviet Union to be not simply a perpetrator of ecocide, but a place where unique landscapes, intellectual debates, and economic practices generated ways of thinking about the environment that remain with us today. Most people have heard about permafrost in the context of discussions about climate change. Over the past 2 decades, scientists have become more and more aware of the possibility that thawing permafrost will accelerate and exacerbate global warming, as these 21st century headlines illustrate. In the Arctic, average yearly temperatures at the Earth's surface are rising at an even faster rate than in the rest of the world. Because of rising temperatures, permafrost is thawing. As it thaws, microorganisms decompose dead plant and animal matter that had previously been kept frozen underground. And carbon from this dead organic matter is released as carbon dioxide or methane, thereby increasing the amount of greenhouse gases in the atmosphere. And this process creates a positive feedback loop. Thawing causes more warming, which causes more thawing, which is what scientists see as accelerating climate change. And so the prospect that sudden massive releases of greenhouse gases from thawing permafrost will lead to catastrophic scenarios of global warming has led people to call permafrost an Arctic or climate or methane time bomb. But what is permafrost exactly? And this question wormed into my brain and refused to go away when I first encountered the phenomenon in historical sources. I was researching the history of economic development in Siberia through the construction of a railroad during the era of the Soviet Union. And repeatedly, the sources I was reading mentioned the phenomenon, which in Russian was called Вечная мерзлота, a very curious sounding expression, partly because of the word Вечная, Vietnamia, meaning eternal, which is a word that has, cultural and religious connotations. And so dictionaries told me that Vietnamese Lata meant permafrost. And so consulting the International Permafrost Association's multi-language glossary of permafrost and related ground ice terms, we learned that permafrost is defined as ground, soil or rock and included ice and organic material that remains at or below 0 degrees Celsius for at least 2 consecutive years. And so permafrost is defined as this aggregate physical structure, ground, with a certain temperature. And moreover, it has a name that suggests longevity, permafrost, and a definition oriented to a short term of 2 consecutive years. So how did this quirky definition, combination of ideas, come to be contained within the concept of permafrost? And so the puzzle grew still more as I dug further. I came across an archival document written by a geologist and a translator for the United States Geological Survey in 1953. And her name was Ina Poiré, and she wrote in 1953, permafrost is a term introduced by the American engineers and is very inadequate. She noted that permafrost has been considered a translation of the Russian Vietnamese ta. But whereas, she wrote, Vietnam means continuous in time or long-lasting or usual, nevertheless, it does not mean fixed or unchangeable, i.e. it does not mean permanent. She asserted that mirzlata in general is one of the least permanent phenomena in nature. Therefore, all terms derived from permafrost, such as permafrostology, permafrozen, permafrost process, do not comply with the actuality, for freezing is not permanent under the present conditions on the Earth known to us. So, if Poiré, writing in 1953, considered permafrost to be an inaccurate term, then how did it enter scientific and popular language? And what does the term suggest about changing understandings of the phenomenon? And so these words challenged me to open up the black box of permafrost and dig into the history behind the meaning of the term and perceptions of this phenomenon. They pushed me to investigate how understandings of this phenomenon emerged and evolved. And what I learned is that the origins of permafrost as an idea are to be found in the history of the Russian Empire, the Soviet Union, and Siberia. We can trace these origins to attempts by first the Russian imperial and then the Soviet state to explore, colonize, and industrialize eastern Siberia. And I argue that encounters with the frozen earth of eastern Siberia gave rise to multiple contested understandings of the phenomenon. A dialectic emerged in scientific understandings of frozen earth. On the one hand, some people thought of it as an aggregate structure, ground. On the other hand, some people understood it as a condition, a process, a space connected to exchanges of matter and energy throughout the planet. And this dialectic was shaped by Russian and Soviet history, politics, and culture, and it gave rise to pluralism in conceptions of frozen earth that persist but often remain unacknowledged to this day. And in this history, language plays a really important role. Problems of language, including debates about scientific terms, reveal different conceptions of frozen earth that grew out of different motivations for studying the phenomenon. Moreover, metaphors and descriptions of frozen earth reveal narratives about human relationships with the rest of nature. In our time, the metaphor of time bomb dominates imaginations about permafrost. In Soviet times, Vietnamese Lata was likened to a sentinel guarding access to treasures that had to be struggled with and defeated. And these metaphors differ from each other, but they both promote a kind of dualist, even adversarial relationship between humans and nature. So instead of treating permafrost as a given, I treat it as an idea that has evolved over time. I do not assume the objectivity, universality, timelessness of permafrost. For this reason, I find it helpful to make a distinction between permafrost and frozen earth. And so I use frozen earth to refer to the phenomenon in nature, the reality, whereby, in some high latitude and high altitude parts of the world, at certain depths, the earth remains frozen throughout the year. And written resources have recorded this phenomenon since at least the 17th century. And they noted that the Earth stayed frozen regardless of dramatic fluctuations in atmospheric conditions, even when the air at the surface became very warm during the summer. And so I intend for frozen Earth to be a non-scientific, non-technical expression. But permafrost, as a historical concept, is one that entered scientific language in the 20th century with a political past connected to Eastern Siberia, the Russian Empire, and the Soviet Union. So frozen Earth became permafrost in a process that was connected to the colonization and industrialization of Eastern Siberia, connected to Russian and Soviet politics and culture, and also to the militarization of the North American Arctic during and after World War II. So I'm going to share part of this story today, developing it in three parts. First, I'm going to focus on a debate about frozen Earth that emerged in the early Soviet Union between two scientists. Then I will look at how and why one scientist's conception of frozen Earth, which embraced an engineering perspective, was adopted and spread under Stalinism and to the United States during World War II. And finally, I will look at how debates about frozen Earth persisted and emerged in the context of the Cold War. So first, also to begin with, I want to take us back to the Soviet Union, the world's first socialist society, also to the 1920s and 30s, at a time when the Soviet Union was undergoing fast-paced economic transformation at the command of a communist regime. This was a time when the term permafrost did not yet exist. In 1927, a scientist named Mikhail Sumgin published a book that for the first time brought together all the elements of the definition of permafrost as we know it today, the definition that I introduced at the very beginning of this presentation. And this definition had three distinct features. One, it defined frozen Earth as an aggregate physical structure, ground or Grund. Secondly, it privileged having a negative temperature as a defining characteristic of frozen Earth. Sumgin explicitly rejected the idea that frozen Earth should be understood with reference to any particular composition. And finally, Sumgin distinguished between three separate categories of frozen Earth. Ground that sustained a negative temperature for hours or days, ground that froze every winter and thawed every spring, and then finally what he called perennially, uninterruptedly lasting frozen Earth. And he wrote, I'm resolved to use one term, Wieczna Мерзлота, for all frozen Earth of an uninterruptedly enduring nature, from 2 years up to the time of the mammoths. So Sumgin created this particular class of frozen Earth as lasting continuously for years, which he called a, quote, permanent phenomenon from the point of view of human life. So the past and the future of frozen Earth were unspecified. What mattered was its ongoing existence with the minimum requirement that the phenomenon be observed for 2 years. And so taken together, these conceptual choices made up the core of Sumgin's understanding of perennially frozen Earth, which he called Wieczna, eternal, Мерзлота. So by the time of his death in 1942, Sumgin would be honored as the founder of the new science of Мерзлотоведение, meaning Мерзлота studies, or more loosely translated, frozen Earth science. But in 1927, he was just a former socialist revolutionary embarking on a new career as a scientist. In fact, to understand how Sumgin arrived at studying frozen Earth and came up with his definition, we have to know something about his political past. Sumgin was born in 1873 to a peasant family in the province of Nizhny Novgorod, west of the Ural Mountains in the Russian Empire. As a young person, he was attracted to populism. Russian populism as a revolutionary movement was defined by opposition to the Tsarist autocracy and to capitalism, and by belief in an egalitarian, self-governing society modeled on the peasant commune. And Russian populism advocated social and economic improvement through reason and science. Despite his disadvantaged background, Sumgin made it to St. Petersburg University with the encouragement and patronage of a noble family. He excelled in math. But because of his participation in populist reading circles, which were officially banned, and also in student demonstrations, he was expelled after 6 terms of study and not permitted to receive a degree. After he was expelled, he joined the Socialist Revolutionary Party, which aimed to overthrow the Tsarist regime. And he was involved in the 1905 revolution in the Russian Empire, trying to organize a demonstration of peasants to demand land and democratic governance. And for this, he was arrested and eventually exiled to the province of Tobolsk in western Siberia. So in 1910, while serving out his sentence in Tobolsk province, Sumgin met up with a group of soil scientists working for the Tsarist government. They were on their way to eastern Siberia, where a section of the Trans-Siberian Railroad was being built. Their job was to evaluate the suitability of the land for agricultural colonization. And the scientists offered Sumgin to work as part of their expedition. And that's how Sumgin ended up in eastern Siberia studying frozen earth. If not for his political activities, he may never have gone down this path. And so the building of the Siberian Railroad and later construction projects in eastern Siberia very much shaped the way Sumgin thought about frozen earth. The Siberian Railroad stretched over 7,000 kilometers from Chelyabinsk in the southern Ural Mountains to Vladivostok on the Pacific coast. It was not just one of the world's longest railroads, it was also the first large-scale infrastructure project to confront the obstacle of perennially frozen earth. And the construction of the Siberian Railroad introduced this practical engineering motivation for studying frozen earth. This motivation continued across the revolutionary divide from the imperial period into the Soviet era. This was because eastern Siberia was seen by both the Tsars and the Bolshevik regimes as being sparsely populated but rich in natural resources. But to accomplish goals like mass settlement and resource extraction required infrastructure for transportation. Less than a decade after the Siberian Railroad was completed, the new Bolshevik government ordered the construction of the Amur-Yakutia Highway. Over 1,100 kilometers long, it also faced problems connected with frozen earth. A few examples from these construction projects help to illustrate the difficulties that engineers faced. First of all, there was the problem that structures built on frozen earth would sink and deform, and known as prasadka or subsidence. This happened when the frozen earth lying underground beneath the structure was exposed to heat and thawed, causing the ground supporting the structure to subside. And it wasn't just the subsiding of the ground that caused problems, it was also the heaving of the ground, known as puchenia. And this referred to the swelling of the ground during the cold months and its subsiding during the warm months. And this happened in cold environments even without perennially frozen earth. But Russian and Soviet engineers found that the presence of perennially frozen earth made heaving even more extreme and hard to predict. During the cold months, moisture in the ground would freeze and expand. And if the ground was very saturated with water, this expansion could be substantial. The ground bulged and exerted pressure on structures sitting on top of it. This bulging was most extreme wherever a lot of groundwater had collected. And since the layer of perennially frozen earth underground was relatively impermeable to water, this meant that groundwater collected on top of it rather than flowing deeper underground. And so this is why bulging could be more intense in places where there was perennially frozen earth compared to places where there wasn't. But engineers couldn't necessarily tell where exactly groundwater would accumulate because frozen earth diverted this groundwater in surprising ways. Sometimes groundwater collected in places where they were, carrying out construction work. There was yet another problem, a form of winter flooding known in Russian as naled, which gets translated into English as icings. And so I just mentioned that frozen earth sometimes diverted groundwater in surprising ways, and groundwater sometimes accumulated on top of frozen earth. Well, sometimes during the cold months, after a lot of the ground had frozen, groundwater still continued to flow through, cracks in the soil and rock. And this groundwater came from rivers or streams or underground sources. Sometimes there was a lot of it. So there was a large volume of water looking for somewhere to go, but small outlets because a lot of the ground was frozen. And this combination of high water volume and small outlets led to a buildup of pressure in some places. This caused the groundwater to burst out into the open, flood onto the surrounding landscape, and quickly freeze, so forming these successive layers of ice. So in developing his definition of frozen earth, Sumgin kept the requirements of engineering in mind. Remember that Sumgin had defined frozen earth on the basis of temperature. He argued that temperature was most important for, quote, fundamental practical interest. Temperature measurements could be used to calculate values such as the allowable stress of the ground at negative temperatures, the design force resulting from the freezing together of soil and construction materials. Given in kilograms per square centimeter, these values were used to establish construction norms. And so a temperature-based definition of frozen earth seemed useful in the context of industrial development. To Sumgin, the short-term orientation of 2 years made sense for the purposes of construction and economic development. For engineers and builders, a perennial phenomenon was meaningfully different from a seasonal phenomenon, and a 2-year existence was a convenient minimum for ascertaining this difference. And so Sumgin represented his view of frozen earth on a map with solid lines and polygons. And here's a scan of the map from his book, and I've also, here's a translated version of this map. So one of the most prominent characteristics of this map was the so-called southern boundary. Within this area, Sumgin depicted three different kinds of variation. Um, you see a solid swath of territory across the far north. This was a bounded area that Sumgin called the region of continuous Vietnamese. And there, frozen earth lay below the surface at every point. Its thickness could reach to over 100 meters. Sumgin further identified two categories of what he called discontinuous tracts. Those where there was a lot of thawed soil within Vietnamese, and then those where, Vietnamese was surrounded by non-frozen earth. So he depicted these variations in frozen earth as, separate classes of polygons that were internally homogeneous. So depth, that is vertical distribution, area or horizontal distribution, were restricted to these broad zones where the proportions of frozen and non-frozen earth seemed to be different. And so this representation illustrated his way of understanding frozen earth, which was all about numerical cutoffs for temperature and time. By collapsing horizontal and vertical variation, Sumgin portrayed Vietnamese as a cohesive region within the USSR. According to Sumgin, this southern boundary was supposed to represent the outlines of frozen earth itself. It showed the boundary between what he called the Massif of Vietnamese with all of its islands of thawed earth, from the Massif of thawed earth. Other scientists were very skeptical about the possibility of pinpointing the exact outlines of something as various as frozen Earth, but practically speaking, having this map of a region of Vietnamese would help tip off engineers to the presence of frozen Earth so that it could be accounted for in industrial engineering. So in Sumgin's view, the southern boundary defining this region of Vietnamese played a key role in uniting science and economic development. But competing visions of frozen Earth existed. According to a geographer named Sergei Parkhomenko, the noun Mirzlata referred not to a structure, ground, but rather to a process of freezing. Mirzlata, he wrote, was a unique process that develops in the upper layers of the lithosphere. So Parkhomenko's notion of Mirzlata formed part of what I call a systems approach to understanding frozen Earth. If Mirzlata referred to the process of freezing in the lithosphere, then it could be understood as linking together multiple elements of nature into a system. These elements included radiation from the sun, minerals of the earth, pressure and humidity in the atmosphere, local relief, vegetation, groundwater, the planet's internal heat. So rather than focusing on frozen Earth itself, Parkhomenko thought it was crucial to examine frozen Earth in connection with its surrounding environment. The entire system of frozen Earth, plus its proximal conditions, Parkhomenko called the complex of Mirzlata, or Merzlotny complex. So Parkhomenko's visual representation of frozen Earth centered on these complexes. And so I think I also have maybe a translated version here. Yeah. So he imagined a complex embedded within a specific locality that consisted not only of the frozen mass itself, but also the layers of Earth overlying it and underlying it, adjacent to it. His strategy for mapping frozen Earth was to devise a dozen classifications of various manifestations of Mirzlata and show their distribution across northern Eurasia. Each category is represented by a different symbol. There are no clear boundaries separating one from another on the map. At times, different icons were interspersed with each other, and the boundaries between them were left ambiguous. So Parkhomenko's map of frozen Earth resembled like a soil map in the tradition of genetic soil scientists in terms of its complexity. And so the disagreements between Sumgin and Parkhomenko arose in part because of the ambiguity of the word Mirzlata. So the noun Mirzlata dated back to the 19th century, first appearing in print in 1838. But usage revealed contradictions within the word. When it was accompanied by adjectives like eternal or swampy or summer or stable, Mirzlata seemed to indicate something material, physical. It was a tangible object with either a prolonged existence in the case of Wieczne Mirzlata or a brief one in the case of Временная Mirzlata. And so here the noun Mirzlata served as a shorthand for frozen soil or frozen ground. But when Mirzlata appeared as Mirzlata of the soil or Mirzlata of the ground, it had a different meaning. Here, Mirzlata seemed to refer not to a physical object, but to a quality, something like frozenness. And so the nature of the phenomenon being signified shifted depending on how the word Mirzlata was used. So Parhomenko especially objected to the expression wieczne мерзлота, eternal мерзлота. He considered it methodologically harmful, since it implants the idea of immobility amid dynamic nature and presents obstacles to an understanding of process. He warned that adopting wieczne мерзлота, quote, returns us to a pre-Lyellian conception of the immutability of nature. To support his view, he referred to the authority of dialectical materialism, the Soviet philosophy of science based on Marxism, and he said, from the point of view of dialectics, this term must be abandoned, and the sooner the better. With its suggestion of a static view of nature, Wieczna мерзлота contradicted the ideological principles embraced by the Bolshevik regime. And to Parhomenko, the adjective eternal prevented an understanding of мерзлота as a dynamic phenomenon, characterized by micro and macro level changes. Furthermore, Parhomenko wrote, it sounds especially strange when it refers to frozen strata reckoned for only 2 years. From a geological perspective, frozen Earth dated not to the depths of time, but merely to the, quote, contemporary Quaternary geological period, which began only 2.6 million years ago. So frozen Earth was therefore no more eternal, Parhomenko argued, than other phenomena of nature. After all, he said, there was a time in the geological history of the Earth when it did not exist, and it was impossible to guarantee that in the future there will not come a moment when frozen rock will disintegrate. So given our own concerns about the thawing of permafrost, Parhomenko's objections to the word wieczna seem all too relevant. Parhomenko also objected to Sumgin's definition of мерзлота that assumed that 0 degrees Celsius marked the point at which the ground froze. But in fact, soil and rock could remain unfrozen, even at negative temperatures, because their freezing depended on the crystallization of water into ice. And as observed in nature, water never crystallized into ice at 0 degrees Celsius, because the presence of salts and other minerals lowered its freezing point. So even if мерзлота were treated as ground, the simple measure of having a negative temperature was insufficient to define its frozenness. So given these objections, why did Sumgin's conception win out? And for this, we'll turn to the broader context of the 5-year plans. So in the 1930s, in connection with the 5-year plans for socialist industrialization, the Soviet Union began building infrastructure and mining resources across the northern and eastern parts of its territory. And all these projects were confronted with the problems I mentioned: subsidence, heavings, icings. And to solve these problems, the USSR Academy of Sciences organized an organization in 1930 dedicated specifically to studying frozen Earth. This organization was headed by none other than Sumgin. As head of the new organization, Sumgin established a term for frozen Earth, wieczne мерзлота. The new organization was called the Commission for the Study of Wieczne мерзлота. It became a committee in 1936 and eventually became the Oberchev Institute for Frozen Earth Science, or Institut мерзлотоведения, in 1939. Thanks to the politics of socialist industrialization, frozen Earth research became institutionalized in the Soviet Union earlier than anywhere else in the world. Soviet scientists began building a discipline centered on frozen Earth, with Sumgin as a leading organizer and science administrator. Under the Stalinist 5-year plans, the regime undertook projects to build infrastructure and extract resources, government in places across the northern and eastern USSR. Government enterprises confronted engineering problems related to frozen Earth, and scientists tried to find solutions and demonstrate their usefulness to socialist industrialization. Funding for research, professional advancement, even personal survival hung in the balance. And so the context of industrialization helps, alongside Sumgin's position in a key institution in the Academy of Sciences, helps to explain why his conception of frozen Earth was adopted. At a time when the practical needs of engineering were prioritized, aggregating varied substances under the umbrella of ground was a shorthand for referring to the part of the Earth that serves as a foundation for buildings. The overall stability of the ground was what mattered the most. The internal complexity could be treated as a black box for the sake of analyzing inputs and outputs. Knowing the temperature of frozen ground enabled engineers to calculate the pressure threshold where it would begin to thaw. And despite the mismatch with the word wieczna, a 2-year existence conveniently marked the difference between the perennial and the seasonal. Considering the deep past, projecting the distant future were unnecessary. As one scientist explained, it's not worth looking 300 years ahead when we have real successive tasks for 10 years. And so we see that the temporal perspective of the five-year plans inform the definition of Vietnamese état. And so during the five-year plan, Soviet propaganda portrayed industrialization as a struggle with nature, nature as something to be conquered. And this heroic struggle with nature became a dominant motif in Soviet propaganda during the five-year plans. The Communist Party called upon citizens to bend nature to their will. I call this the rhetoric of conquest. This rhetoric of conquest was also applied to permafrost. In 1938, Sumgin published a book entitled The Conquest of the North, parentheses, in the region of Vietnamese état. It was written with a journalist named Boris Demchinsky. The book demonstrates several ways that the rhetoric of conquest was applied to permafrost. It showed human beings engaged in a struggle with frozen Earth. It used anthropomorphism, portraying frozen Earth as a live opponent, and it endowed frozen Earth with agency, showing it to be something that was actively thwarting industrialization. So, for example, Sumgin and Damchinsky wrote in their book that there's hidden wealth in the earth, but Vietnamese état stands as a sentinel, forbidding access to treasures. Thus, a struggle against it has begun. They emphasized that frozen earth was a live enemy. They wrote that any work on the surface of the earth provokes a reaction on the part of Vietnamese état. They emphasize the dynamic and dangerous features of frozen Earth, warning that nowhere else on the globe is it possible to observe such peculiar and inexplicable violence on the part of water as in the regions of Vietnamese état. So when people went into regions with frozen Earth, they crossed paths with this animate and hostile environment. So for Sumgin, this rhetoric of conquest was useful for establishing and attracting state resources to this new discipline of frozen earth science. The more he emphasized the struggle with Vietnamese état, the more he portrayed Vietnamese état as a dangerous enemy to be defeated, the more he justified the need for expertise, and the more state resources he attracted to an emerging field. And so that was part of his motive for using this rhetoric of conquest. And this image of frozen earth that was fostered by the rhetoric of conquest also helped to make concrete his notion of Vietnamese état. It helped bring the phenomenon as defined by Sumgin to Soviet public awareness. The expression Vietnamese état helped to link the Soviet struggle against nature and the struggle against time. So historians of the Soviet Union have shown that notions of time occupied a central position in the Soviet project. The ideology of Marxism, Leninism, and Stalinism centered on what scholars have called a charismatic rational conception of time. This charismatic rational conception of time combined the linear time of modernity with the aspiration to transcend it. So under Stalinism, this goal of meshing the rational and the charismatic was manifested in the five-year plans. The party state urged that production norms should be overfulfilled in order to realize the five-year plan in 4 years. The rational plan in a kind of charismatic time. And so socialist industrialization was about applying labor discipline toward achieving this revolutionary compression of time. So in contrast to this charismatic rational conception of time, Vietnamese l'état evoked the cyclical time of nature. Vietnamese l'état was eternal. It was set apart from the forward movement of socialism. So by struggling against Vietnamese l'état, Soviet society also struggled against this undisciplined time. So these cultural factors enabled Sumgin's conception of frozen earth to be adopted in the Soviet Union. But the engineering imperative also enabled Sumgin's ideas to spread abroad. In the 1940s and 50s, the US undertook several large-scale constructions projects in the Arctic and the subarctic for military purposes. For example, it built a series of airfields from Montana to Alaska. It constructed the Alaska-Canadian Highway, 2,400 kilometers. It laid the Canal pipeline, 896 kilometers long. Later, it built a series of radar sites across northern Canada, known as the Distant Early Warning Line. And because these projects took place in regions with perennially frozen Earth, the U.S. Army asked the Geological Survey for information about this phenomenon. And the USGS found that most current research was produced by Soviet scientists. So when the US and the Soviet Union became allies in World War II, the US received scientific literature from the Obruchev Institute, where Sumgin worked. To make that research accessible to English speakers, the US Geological Survey turned to Simon Mueller, who was a professor of geology at Stanford University. Mueller was born in 1900 in Blagoveschensk in the Russian Empire, but he emigrated to the US in 1921. And in 1943, he completed what was known as Strategic Engineering Study Number 62, Permafrost or Permanently Frozen Ground and Related Engineering Problems. And the purpose of this report, he wrote, was to acquaint those unfamiliar with the Russian language with frozen Earth. He noted that technical terminology pertaining to frozen ground phenomenon is for the most part new and represents either a more or less free translation or direct adoption of terms widely used in Russia. Mueller created the word permafrost based on the expression Вечная мерзлота. According to Mueller, the literal translation of Вечная мерзлота was permanently frozen ground. But he found the expression too long and cumbersome, and for this reason, a shorter term permafrost is proposed as an alternative. While coining this new English word, Mueller preserved the definition that Sumgin gave, soil or deposit or bedrock where temperature below freezing has existed continuously from 2 years to tens of thousands of years. And this definition taken by Sumgin, still the definition of permafrost today. So the English neologism permafrost appeared in 1943 as a loan translation of the Russian Вечная мерзлота. And yeah, this is a schematic of how this went from Вечная мерзлота to permanently frozen ground to permafrost. But the story doesn't end here. The dialectic persisted. After World War II, scientific exchange between the United States and the Soviet Union became disrupted by the onset of the Cold War. At the same time, both Вечная мерзлота and permafrost became contested terms. So in North America, one of the most vocal opponents of the term was Harvard geologist Kirk Bryan. He called the term permafrost an etymological monstrosity, combining a Latin root with the English word frost, none of which meanings refer to the ground. Furthermore, what made frozen Earth important to study was its process of formation and not simply the object itself. So scientists, he argued, needed language to discuss the dynamics of frozen Earth. With permafrost, Bryan argued, a verb or verbal noun cannot be made, and without the ability to transform into a meaningful verb, the word permafrost actually hindered communication about an essential feature of frozen Earth, its dynamism. So Bryan's objections were glossed over in favor of expediency. Robert Wallace of the U.S. Geological Survey wrote to Bryan that the simplicity of permafrost enhances its value immensely. It has been readily adopted and understood by engineers and laymen in Alaska who are concerned with various permafrost problems in construction and engineering and mining. So for Wallace, the essence of frozen Earth consisted of its material reality in the ground as an engineering obstacle, and permafrost was a vivid way to evoke its presence. So permafrost quickly became part of the lexicon of the U.S. military and government. In 1948, the Alaska Terrain and Permafrost section of the USGS was created. In 1949, the U.S. military organized the Snow, Ice, and Permafrost Research Establishment, or SIPRI, and these offices and agencies helped to institutionalize the term permafrost. On the Soviet side, in the context of the hardening of the Cold War, the Soviet government started issuing decrees restricting the publication and sharing of state secrets, including scientific research. In 1948, the Communist Party launched a campaign for creative discussions in the sciences. And this campaign aimed to ensure that Soviet scientists demonstrated a commitment to Marxism, pride in Russian achievements, and service to the state. As scholars in Russia have been expected to do in our times. And so these developments affected the Oberchev Institute for Frozen Earth Science. In 1948, Andrei Markovich Chikatilo, who was the deputy director of the institute after Sumgin's death, he was accused of being anti-patriotic, of showing servility and kowtowing to foreigners because he had sent articles abroad on multiple occasions between 1943 and 1948. His accusers, fellow scientists, specifically mentioned Seaman Mueller's book as an American compilation on frozen Earth done entirely on the basis of our Soviet work. They suggested that Chikatilo was to blame, and that year Chikatilo lost his position as deputy director. Soon afterward, scientists at the Oberchev Institute were encouraged to perform Bolshevik criticism and self-criticism. And in this context, the debate on the terminology of frozen Earth was reopened. A younger generation of scientists, led by Pyotr Filimonovich Shvetsov, wanted to get rid of the term Vietnamese that had been established by Mikhail Sumgin. Shvetsov argued that the term Vietnamese was misleading and ambiguous. Vietnaya literally meant eternal, but frozen earth could not be eternal because its presence depended on a changing climate. Furthermore, Shvetsov discovered that the noun mirzlata had multiple meanings. Sometimes it referred to a physical substance, such as soil or rock, and sometimes it referred to a condition of the soil or rock, coldness or frozenness. And this kind of ambiguity, Shvetsov argued, was unacceptable for a scientific term. So in the 1950s, Shvetsov tried to revise the terms and framework of frozen earth science to accord with Marxist-Leninist ideology as he conceived it. He advocated an Earth systems approach to studying frozen Earth. Whereas Sumgin had emphasized time and temperature in his conception of frozen Earth, Shvetsov focused on space and heat. The Here's a kind of translation. The object of study, Shvetsov said, was not frozen Earth itself, but the frozen zone of the Earth's crust, the cryolithozone, he called it. The cryolithozone was not a structure, but an envelope where exchanges of heat took place between different spheres of the planet, including the lithosphere and the atmosphere. And through its participation in heat exchange, the cryolithozone made up part of the system that was the Earth as a whole. And Shvetsov called the science of the cryolithozone geocryology. Citing the principles of dialectical materialism, he tried to supplant Sumgin's discipline of Mirzatvedienia with his vision of geocryology. So making the cryolithozone rather than Mirzlata the object of study meant shifting the epistemological framework of frozen earth research. Whereas Sumgin focused on time, Shvetsov focused on space. Where Sumgin was concerned with temperature, Shvetsov was interested in heat and energy. Shvetsov acknowledged that soil and rock could remain frozen for different lengths of time, with a key distinction between the seasonal and the perennial. But instead of treating the period of existence as a primary characteristic of frozen Earth, he foregrounded the spatial reasons for temporal differences in frozenness. Frozen soil and rock lasted for different amounts of time because, depending on the location on the planet, they were exposed to different levels of solar radiation. And so, to highlight this spatial relationship, Shvetsov depicted this quarter cross-section of the Earth, showing the North Pole at the top and the equator along the bottom. So, the zonal quality of frozen Earth revealed itself along this north-south axis, as well as in the interior envelopes of the planet, from the upper layers of the soil to the lower layers of rock. Seasonal cryolithozones, which contained soil, were located near the planet's surface at middle latitudes. And these regions responded to seasonal fluctuations in levels of solar radiation so that the soil froze in winter, then thawed in the summer. Perennial cryolithozone, which contained rock, were deeper beneath the surface, and they were at higher latitudes. They received less solar radiation, which enabled frozen rock to maintain its condition for years. So time for Shvetsov was a function of space. Time, the duration of frozenness was a function of space. So Shvetsov advanced this framework of geocryology by using the political rituals of late Stalinism. So the campaign for creative discussions began after the Central Committee of the Communist Party subjected a philosophy textbook to criticism in 1947. And then in 1948, as part of this creative discussion campaign, the Communist Party infamously endorsed Trofim Lysenko and his attacks on genetics at a meeting of the All-Union Academy of Agricultural Sciences. So a few months later, Shvetsov referenced these debates at a meeting of the Oberchev Institute. He declared the necessity of uncovering mistakes in the Institute's work by practicing Bolshevik criticism and self-criticism. Also, as part of these campaigns for creative discussions, in 1950, Stalin published a series of articles in Pravda intervening in a debate about linguistics. And so the following spring, the Oberchev Institute held a meeting dedicated to the anniversary of the publication of Stalin's genius works. Shvetsov called on scientists to strive for the same sharpness, succinctness, precision, clarity, accessibility, harmony, logic, and depth that Stalin had displayed in his thinking, and citing Stalin's writings to critique the existing terms of frozen earth and frozen earth science, declaring them completely unsatisfactory. And so Shvetsov built this case for geocryology by leveraging the contingent political circumstances at the time. So, we've seen that these Soviet American controversies about the terms Vietnamese and permafrost were part of a longer standing debate about the nature of frozen Earth, whether it was a structure or condition, a substance or a space, ice or Earth. And these debates took place in isolation. Linguistic barriers, political barriers, as well as Cold War priorities prevented a full collective discussion about the nature of frozen Earth at a key moment. Under such conditions, permafrost, despite its contested origins, became a global scientific term. So to kind of revisit my findings, we've seen that multiple contested ways of understanding frozen Earth emerged historically, and that these scientific understandings of frozen Earth were shaped by Russian and Soviet history, politics, and culture. And that scientific terminology and language revealed different motivations for studying frozen Earth and different narratives about human relationships with the rest of nature. We learned that the English neologism permafrost appeared in 1943 as a loan translation of the Russian Vietnamese l'état, and the concept of permafrost came about through twists and turns in history, loaded with political and cultural meaning that later became obscured. And to work towards wrapping up, I'll point out that occasionally in popular discourse there are sparks of recognition that permafrost is a curious term, especially in the context of global warming. For example, sources will say that permafrost is no longer permanent and starting to thaw. But I would argue it's not that permafrost is no longer permanent. It was never permanent to begin with. Permafrost was a human construction when it came to frozen Earth, and it was a very contested one. As I've tried to show, some scientists contested the notion of permanence as an intrinsic characteristic of frozen Earth. And historically, there were many people, including both European scientists and local peoples living in regions with frozen Earth, who recognized the dynamism of frozen Earth as its inherent characteristic rather than its stillness. And stillness and permanence were colonial constructs of a particular kind. The structures and processes of colonization and industrialization elevated some ways of knowing and marginalized others. They specifically elevated expectations of stillness and structure, the idea of frozen Earth as permanent, as a concrete body. And perhaps it's necessary to embrace the dynamism of frozen Earth rather than perpetuating notions of its permanence or expectations of its permanence. Doing so might point to ways of living with frozen Earth beyond aspirations of conquest and control. And so I'll wrap up my presentation here and maybe leave us with a couple of questions that I'd be curious to hear your thoughts on if you care to think about them. One is kind of like, yeah, how does the story of permafrost, how might it fit into your prior conceptions of the USSR or modify them? And then more broadly, what is to be done, if anything, about the fact that the concept of permafrost originated in and is connected to the colonization and Soviet industrialization of Siberia, to make the idea and term seem any less useful or valid to you? These are some questions I have. So thank you for your attention.